So this is continuing chapter 16. For this discussion, you need to get your Ka, Kb tables out for this discussion so you can kind of see where I'm going with this. This is probably the most tricky part of acid-base chemistry, at least the chapter 16 portion, and it has to do with salts. Okay, so ionic compounds, when they dissolve in water, either they form acidic, basic, or neutral solutions. So up on top here, if you want to write this down, so when an acid reacts with a base, you always make water and a salt. That was the traditional neutralization reaction. Well, this salt dissolves in water. We're assuming ionics dissolve in water, so you produce a cation and an anion, a positive and a negative. Well, when this positive and negative anion are in water, do they produce hydronium ion or they produce hydroxide or they don't produce either? Okay, so that's what we're focused on here. So before we just wrote the salt in there, we didn't think about it, we didn't consider it. So I'm going to kind of walk you through how do we know if it's acidic or basic or neutral from what it is. So I'm going to start with what we call the neutral salts, So the neutral salts are going to be a combination of two ions. The cation is coming from the strong base, so that's going to be something from column 1 or column 2 on the periodic table. And the anion is coming from a strong acid, so one of the 6 strong acids that we know. Okay, so a neutral salt really comes from a strong acid reacting with a strong base. Okay, so let me walk you through a couple examples to show you how you could kind of spot this. So these are my salts here, KCl, NaCl, and KNO3. Well, if I take the KCl, I could break it up into its 2 ions, K plus and Cl minus. Well, the cation is coming from a strong base. Well, what strong base is it coming from? KOH. Now, KOH is a strong base, so that means when I write the arrow, it's only pointing in one direction, and it is K plus OH minus, which means when that K plus is in the presence of water, okay, there is no reaction. That K does not get together with the OH to make KOH again, okay? Likewise, the same thing is talking about with the strong acid. So the strong acid that produced the Cl minus is HCl. Again, it produces H plus and Cl minus, and the arrow is only pointing in one direction, okay? So with strong components, you get no reaction with the water, okay? So that means your pH is 7 with these salts, okay? Because you don't produce any OH and you don't produce any H3O+. So following through, NaCl. So I have Na plus and Cl minus that are floating around in that beaker of water, okay? Do they react with the water? No, because the Na is coming from NaOH, that's a strong base, and the Cl is coming from HCl again, okay? So there is no reaction, so this is a pH of 7. KNO3, okay, K plus and NO3 minus. This has come from potassium hydroxide. Where is the nitrate coming from? Well, that's coming from nitric acid, okay? So if you have a salt that is coming from a strong and strong component, you're going to say the pH is 7. It is neutral. So where it gets more interesting is for basics and acidics. So basic salts are coming from a strong base. So again, it's going to be a cation from group 1 and 2. But then the anion is going to be the conjugate base of a weak acid. Okay, so these are going to be a little more hard to identify, I guess. So again, these are the salts that I'm talking about. So NaCN, okay, if it's in an aqueous system, it's breaking into Na plus and Cn minus. So we're trying to figure out which of these is going to react with water. Well, the Na is coming from a strong base, so that I don't need to worry about. So I could X that out, okay? That's not going to do anything with water. But the Cn minus, okay, that's the interesting one. So if I take Cn minus and I react it with water, okay? All right. Does Cn minus have an H? No. Okay. So the only thing it can do is take on an H, right? So it could become HCN by taking on an H. Well, if it takes that H from H2O, what else are you left with? OH minus, which makes it a basic solution. So your pH is going to be somewhere above 7 if you dissolve NaCN in water. Okay, so what gets confusing is you are producing HCN. Well, HCN will pop off that H, but this OH is going to dominate that system. So that's why we say that this is a basic salt. So what about NaC2H3O2? Okay, so again, Na plus and C2H3O2 minus, okay? Again, I don't need to worry about the Na, I just got to worry about the acetate. So C2H3O2 plus water. What is it going to do? Again, this H in the middle is not acidic, so it's going to take on and make acetic acid, and you're going to make OH minus. Okay, so your pH is going to be basic. Okay, so when I dissolve sodium acetate into water, my pH is going to be greater than 7. So see if you can process KF, and I will come back and show you the answer. So KF, the K comes from potassium hydroxide, okay? So that potassium hydroxide is not going to be a factor here. So the F minus is the only thing we need to pay attention to. So F minus is going to take on an H from the water to produce HF. And so the predominant species is going to be OH. Again, the HF, the H will come off eventually, but the first equilibrium we have here is going to be the production of OH. Okay, so then what about acidic salts? Okay, what do these look like? Okay, well, they are going to have a conjugate acid of a weak base. Okay, and then their anion is coming from a strong acid, so we don't need to worry about the strong acid component. Okay, so the strong acid's over here. So I have NH4Cl. Again, NH4Cl breaks up into NH plus and Cl minus. So it is the NH4 plus is the conjugate acid of a weak base. The Cl minus is coming from HCl, so I don't need to worry about that. I don't need to worry about that. So what does NH4 plus do in water? Well, it's at equilibrium. It's going to donate that H plus to make hydronium ion. So this hydronium ion, H3O plus, is going to make this a pH less than 7. Okay. Yes, you do produce ammonia. You do produce ammonia, and ammonia would act like a base, but the predominant species in the first equilibrium is going to be that hydronium ion. Okay. So the good news for you guys is the most common conjugate acid of a weak base is going to be the ammonium ion. Okay, so again, the NO3 is coming from nitric acid. Don't need to worry about that. So really, it's going to be the same equation over and over again. Okay, so it's going to be the production of that hydronium ion to produce an acidic salt. All right, so what happens if you have both of them coming from a weak component? So what if they're both coming from weak bases and weak acids? Well, that's where you're going to have to use your table. Okay, so again, the table on the left, these are Kas. On the right, these are Kbs. So again, if I have HSO3 minus being a weak base, it's taking on an H. If it's H2SO3 and it's in a Ka column, that means it's releasing that H. So what you have to do is you have to see, comparing your weak base and your weak acid component, to see exactly who is going to be the bigger component. So if your Ka is bigger than your Kb, it's going to be more acidic, it's going to release the H. If your Kb is greater than the Ka, it's going to take on a H. If they're exactly equal, it's going to be neutral. So let's look at this example here, okay? So if I have NH4F, And I gave you the KB for NH3, and I'm showing you this for a reason. And the HF for your Ka is 7.2 times 10 to the 14th. Well, we know that Ka times Kb always gives me Kw. So if I need to know NH4 plus, this is, you will get the table, but if you don't get the table on the AP test, this is how you find the other thing. So if I want to find the Ka of NH4 plus, because that's really what my salt is, I divide my Kb value here of NH3 into here to find my Ka. So this is my Ka value. What is my F minus? Well, I were given a Ka, so if I divide that in there, this is my Kb. So 10 to the negative 10th or 10 to the negative 11th, who is bigger? Well, 10 to the negative 10th is a bigger value. So what that means is, since this is bigger, this is going to dominate the equilibrium. So NH4 plus water becomes NH3 and hydronium ion. Okay, so you're going to have more hydronium ion than you do. F minus plus water becomes HF plus OH minus. So it doesn't mean the other equilibrium doesn't take place, because both of these do happen. They're both in water. They're both going to do this. But what you're going to see is you're going to have more H3O plus. So you're going to have more H3O plus than you do the OH minus. So that is why you're going to consider this particular salt, if I were to dissolve it in water, is going to be considered acidic. Okay. So the trickiest ones are the ones that are coming from weak components, and you're going to have to compare the Ka and Kb value to figure out who is bigger. Now, if they happen to be exactly the same, then you would say the pH is 7, that it is neutral.